地震是一个人类尚未解决的难题之一。现在随着科技的发展，常言道，就是上天容易，入地难。我们现在的宇宙飞船，实际上已经可以驶往星际了。但是现在最深的采掘深度仅仅达到12公里，实际上是仅仅达到了表皮。
大家从观念上认为地震就不可预报，你在这做这事就瞎闹，你认为你这个东西就瞎弄，不可能的事情，绝对的，我坚信一定会成功的。如果我们提前能够把位置说准、预报了，那么就会有这么多人免于死亡。
もしくは地下にどういう生命の限界はどこだ、火山のメカニズムを世界の環境が変わってきたのか。南海地震は 100% 起こると確信しています。どれくらいのインパクトがあるか。
You have to go to the field to understand what an earthquake has done, to be able to predict an earthquake and give a warning. That is the seismologist's dream. But right now, there is no such thing. If we are able to tell that earthquakes may happen here, you are basically telling that you are able to save lives. It will change everything. Every grain that you find on the earth has a story to tell. So when you go to an earthquake area, you are basically trying to look around for any kind of evidence that the earth might leave. But you need to know where to look at, what to look at, and you need to have an eye to look at it. So it is like a detective story to find the clues.
I would call this a crime scene. It's like a murder perpetrated by somebody, but you need to see who has done this. So I always call myself as a detective, Sherlock Holmes, who has a sixth sense to understand what has gone wrong here.
What do you do in a crime scene? You look around for any clues left behind unknowingly. And then work backwards to find out what may have happened.
Sherlock Holmes comes with a broad picture of the murder scene, but the Watson also asks certain questions which make Sherlock Holmes think more about it.
Because I'm observing everything, I would point him to something that is useful. So he said, okay, you are like Watson for me.
So that is how the chemistry works.
What happens in the field? You learn and then you get prepared. So you have the ability to prepare for the worst in future.
So this area is not very far from the epicenter. Yeah. So the shaking was very intense. Very intense, and many of the buildings which fell off.
We are trying to understand things which are not understood properly. And once you've gotten into this field, you see that there are a lot of mysteries surrounding the earthquakes.
What happened after the earthquake? Ask him where people left and they were here.
यहाँ के मतलब कितनी पॉपुलेशन थी, कितने लोग रहते थे यहाँ पर?
यहाँ तो बहुत लोग 12-13 लोग थे।
और कितने लोग की डेथ हो गए?
तकरीबन 700-800 लोग।
700-800 लोग। 12,000 people were there.
12,000 was here. How many were
died? 700.
700 died here.
छोटे बच्चे बहुत चले गए, 300 तो बच्चे चले गए। छोटे-छोटे बच्चे ध्वज मंदिर में थे ना, वो चले गए तब के। अभी डर लग रहा है इसलिए कि पड़ोस में अगर कोई चाहिए ना रहने वाला तो चाहिए ना कोई। यहाँ तो पूरा गांव नष्ट हो गया था।
आपका घर कहाँ पर?
मेरा घर इनके पीछे।
इनके पीछे। तो आपका उम्र कितना था उस टाइम पर?
30 साल का।
I've been working on earthquakes for the last 35 years or so. It is my passion to work on earthquakes, to talk on earthquakes, and to interact with the public on issues related to earthquakes. It's my love. It's my first love. तो आपका घर तो पक्का मकान था? कच्चा मकान था और पूरा गिर गया?
पूरा गिर गया।
और कौन-कौन इसमें
2 मकान थे, इसमें सब आ गए जितने भी हमारे फैमिली का परिवार थे ना। ये जो बंगला दिखाई दे रहा है, ये बंगला है ना, उसके पीछे मेरी बहन रहता था, मेरे भांजे रहते थे, मेरे मामू रहते थे। वो क्योंकि मकान में बैठे थे, अचानक जब भूकंप आया ना, बाहर निकले तो देखो कि ये कच्चा मकान था, बाजू में बहुत बड़ी बिल्डिंग थी, पूरा बिल्डिंग उसके ऊपर गिर गया। 3 दिन के बाद तो मिले वो सब।
कौन कौन आपको कितना मौत हो गया आपका घर में?
हमारे घर में 7 मौत हुए।
7।
तो उसमें क्या हुआ, जो देखो सर 2021 की साल थी बराबर, और सुबह में 8:40 पे ये ध्वज वंदन के लिए लोग और लड़के सब गए थे स्कूल में। तो अचानक शुरू स्टार्टिंग ऐसा हुआ, जब हिला ना तो हमें ऐसा लगा कि कुछ अचानक आफत आ रही, मगर जब 1-2 मिनट के बाद ही पूरा मकान नष्ट होने लगा, लोगों की चीखें निकली, तो नजर नहीं आता था कुछ, ऐसा धुआं निकला, पूरा गांव में धुआं निकल गया था। ऐसा हालत हुआ, ये तकरीबन 4 मिनट चला था। ये तो अचानक आता है ना, अभी अपने खड़े हैं, अचानक अगर भूकंप आ गए, आप कैसे कह सकते हो ऐसे कब हुआ, क्यों हुआ, कैसे हुआ, कब हुआ, पता चल सकता है अपने को।
It is a sudden event happening for which we don't have any clues. There are too many unknowns. If it is like a cyclone, typhoon, or even an volcanic eruption, they can be observed on the surface. But for earthquakes, it is happening several kilometers below the area of observation. The Earth is a jigsaw of huge tectonic plates, constantly moving and shifting. They collide and violently push into each other, creating an enormous buildup of pressure. Eventually, the rocks can't take it anymore. There is a sudden release of energy, an earthquake. If it is a moderate earthquake, like a magnitude 4 or 5, you may only feel a vibration. If it is a magnitude 6 to 7, the shaking power is 10 times more. So 6 to 7 is a huge jump. We are actually standing, it's about 10 kilometers away from the actual epicenter. I am immediately reminded of the great saying, earthquakes do not kill people, but buildings do.
This is actually a very textbook case of a destruction. The acceleration was so high, beyond 1G. So that's why it got lifted up and it got toppled.
This is a zone of maximum destruction, and you can see all around here, almost all the houses got destroyed here, and they have a major damage. And these are all not very old constructions. You can see that these are constructed maybe 2 to 3 years prior to the 2001 Bhuj earthquake.
Well, that is why India is different. And because of its extreme population, earthquakes also result in a lot of damage. Because it's very densely populated, constructions are not up to the standard because of the economic, social conditions. So, there is a lot of, you feel very guilty that why is it happening? You feel that there is something else you need to do. These are all very loose, actually that is why the acceleration was also very high. The temple was sitting on this ground, it would have been saved. Today is the first time I'm again coming back to the same places where lives were lost and looking at it from that perspective, that we have never done before. So I have become very, it's very unsettling for me to recount how it affected people. It's so difficult to visit a place, where memories from an earthquake is preserved. Yeah. The tragedy comes live in front of you once again. Seismologists learn how an earthquake has impacted humans and also structures. But you are walking through a region of death. We have walked so many earthquake sites. We laugh and we cry and we also learn. So I think this is the place that taught us so many things.
Yeah, come.
earthquake is a universal thing. What happens in China could be very similar to what happens in India. So sharing knowledge is like learning from other people's mistakes or other people's histories.
中国也是一个构造发育的地方，地震呢是多发，所以世界上有1/3的漏源地震呢发生在我们国家。查过的，每天估计有好几万人。要发生7.5级或者8级地震，那么会造成大量的这个建筑物的破坏。根据以往的一些情况，例如5.12地震的时候，有很多人就恐慌跳楼，所以这个恐慌造成的伤亡，在西安当时是最主要的。假如说地震前的3-5天，甚至的提前3-5个小时，我们能捕获到这样的一个地震前兆，能够准确预报的话，那么就可以大大的减少这个人员的伤亡。所以这一项工作呢，也是我这个终生要研究的事情。经过多年的努力，我相信我们会取得突破的。大家从观念上认为地震就不可预报，你在这做这只是瞎闹，认为你这个东西是瞎弄，不可能的事情。这是最大的问题。过去我们有一个老领导说过一句话，就是说地球假如是个鸡蛋的话，我们的人类就相当于这个鸡蛋上面一个细菌。地球的内部深部，你看这个蛋壳、蛋清、蛋黄什么情况，那很难知道的。地震的孕育发生的机制上，它发生的过程上，目前我们地震预报的这个前兆，大家都在找。但找了很多，目前就是咱们研究最好的还是重力。我们发现的这个极低频的这个扰动异常和地震呢具有密切的关系，就是做这些方面人特别多啊。地震预测在中国应该来说在世界是处于领先水平。现在我们党内工作这个重点工作里边，又把地震预报提到这个首要的位置。既是科学研究的迫切需要，也是我们国家的重大需求，更是我们这个科学家的这个应该肩负的这个社会责任。我们处在这个2个地震带的交汇部分，大家从这张图可以看出来，中国处在一个欧亚板块的一个东南沿，也就是喜马拉雅地中海地震带和环太平洋地带的一个交汇部分。世界上有80%以上的地震发生在环太平洋的火山地震带上，在亚洲约有10亿人生活在这一危险区域。
我々まさに、今高知にいるんですけれども、そういう南海トラフ、いつ来てもおかしくない最前線にいるっていうそういう状況です。我々日本人は2011年に東北の大震災っていうのを目の当たりにしました。2万人以上が亡くなって津波が襲って町がなくなった。全く同じことが南海トラフでも起こっても全然おかしくない。実際起こると思ってます。南海地震は 100% 起こると確信しています。もう大学学部の3年生の時に 阪神大震災1995年に、神戸を襲った大きな地震があって、地球の動きでこんなに物が壊れるんだっていうことをもう間近で目の前で見てですね、興味が地質学から地震の方にふっと移ったというか。ジャムステックと高地台で総勢でだいたい100名ぐらいがここの施設内にいます。こういった試験機を置いた部屋がいくつもあるんですけれども、今から地震断層運動っていうのをですね、実験室で再現するんですけど、実際海洋のプレートの中にこういう石があるんですね。それを今からこすり合わせてずるっと滑らせるっていう、そういうことをやっていきます。だいたいですね、距離にして800キロメーターぐらい、フィリピン海プレートっていうプレートがユーラシアプレートに沈み込む、こういうプレート境界で大きな地震が起こるっていうような、まさにそういう最前線。どれくらいのインパクトがあるか。大きな揺れが襲う地域っていうのはもう東京、関東からもう九州まで、その津波の高さが30メーターを超えるというような、そういうシミュレーション結果もある。もうすごくやばいと思います。社会としての機能が完全に失われる。南海トラフではそのような高速の滑りっていうのをこの実験で再現しました。弱くなることによって貯められていたエネルギーがバンと出るんですけれど、地下10キロとか20キロでどういったことが起こるのかっていうことを我々探るっていうことをしています。我々の実験の研究から地震についてどういうことが分かるか、予測につながるかっていう、直接的にですね、今予測につながるっていうような、そういうことまでは、まだ難しいと思ってます。我々そんなに簡単に自然のことを解き明かせるっていうのはないと思うので、
より多くの手がかりを得たいのであれば、私たちは海底面からより深部まで目を向ける必要があります。あるプロジェクトでは、陸から南に約 80km の南海トラフプレート境界断層直上の掘削地点まで移動しました。アジアで最も壊滅的な地震の発生源です。我々は海底下の岩盤を数千メートル掘削しました。プレート境界断層からコアを採取しました。
I joined the 3 group expeditions. We work in 24 hours, and each expedition is like more than 2 months. So every course are so valuable. Now we will go to the core container and take the course we need to observe today. In Japan, we have a huge earthquake and it always comes and come again. So we wanted to try to find all the earthquake patterns. We need to decipher it. We need to read and reread, such like a book. Just our book is a course. This course we take from the Nankai Trough, from the more than 2,000 water depths. Section by section, you can see this kind of event here is different from the normal sediment. When earthquake happened, there are a few sediments may transport downward into this basin, and we can find the event is one by one and again and again. We can see the clear bed here. So also we can see the changing part. from the muddy part to the sandy part and change to the muddy again. So each event is related to the old earthquake.
例えば南海トラフで起こる大きな地震100から150周年っていうことをお伝えしたんですけれども、怖いものっていうのは間違いないんです。
We have a similar problem to Japan. We also have the potential of the large earthquake in the future is a big threat for Indonesia. Lots of people think that I am like a magician that can predict when it will happen. I know the potential, I know the forecast, but I couldn't predict earthquake. Nobody can. For a long time, predicting earthquake is a thing of fiction. Even 300 BC, a Greek historian said that some animals behave like crazy, run away like hell before the earthquake occurs. But seismological global networks start to grow rapidly since 1960. So there are lots of advancement in science and also technology. Now, scientists have developed 3D mapping of fault lines and satellite images from space. And we can look further under the surface than ever before to see patterns. But right now, we could not predict earthquake accurately. So if there is somebody who said that they can predict earthquake, or he can or she can predict earthquake, I think it's not true. You should not believe them.
因为说实在的，这个在地震预报方面探索的人很多，但是目前还没有哪一个是成功的，所以这一辈子在做跟地质灾害有关的事情。尽管也学了地震，但并没有把它作为己任。一开始对地震的可能就是知道这是地震自然现象，和自己的关系不是很密切，所以从这个时候呢，我们就开始把我呢作为自然资源部呢被派到这个甘肃进行应急救援。你知道后来这个，尤其是5.12这个汶川地震以后，自己到现场。2010年的这个玉树地震，我又第一时间赶赴了这个现场，所以亲临的这个救灾的过程，目睹了那些惨烈的这个灾害以后，就对这个感兴了兴趣。看到了这么多死难的这个同胞吧，是吧？这个想着能不能在这有所作为。如果地震能预报，那就更好了。科技在发展，探测的技术方法也在发展，是吧？出现了信号、异常信号，我们就在预测什么时间，在什么地方，有多大的级别，坚信一定会成功。
我们去丰峪口，我们这个集体品异常这个监测站，在这个秦岭这个山地和关中盆地一个交汇部位上，也是一个活动锻炼带，所以在这一块呢，另外一个原因就是这块比较清静，为外边这个人的干扰比较少一些。好，杨博士，我们这一次去，那个该带的东西都带了吧？
都带了。该有的这个监测设备的这个调试仪器，还有一些电脑的这个数据都带了。开始是在5年多前，就是当时就是刚开始接触张教授嘛，他就跟我说了一个事情，他说就是经过他们的探测，就是发现了一种信号，一种重力信号，这种信号呢极有可能预示着某一些地震的发生，在某种意义上可能会揭示这个地震的一些孕育，所以说我就很感兴趣了。我的家庭呢，祖宗3代都是从事这个地质工作研究，所以说做了这么多年，然后一直到跟随到这个张教授，
怎么样，张老师？路上顺利吗？
就是感到自己要加紧努力，我们尽快破解这个地震这个预测预报这个难题。我们现在说的地震的前兆，老鼠过街呀、乱跑呀、加紧这个声序等等的一系列东西。但是这些呢，你要说把它作为地震的前兆的话，那么天天可能都有地震预报。我们它的前兆是啥？从我们观测的数据来说，就是在地震之前有一个重力的异常，这个是很微弱的，所以这个在一般仪器是观测不到这个变化。这也是一种重力仪，我们移动在野外去，流动的进行这个重力监测的。放在那以后5分钟，我们就可以测出来这一块的重力。重力是由地球的质量产生的。那么重力呢，并不是一成不变的，但是这种变化它是有规律的一个变化。在地球巨大板块的运动过程中，重力会随之发生变化。那么重力的飙升，就可能预示着地震的来临。那么在地震前1天到30天范围内，它总会发现一些异常、一些扰动。这一套设备的监测和这些异常数据，是我们整个做地震预报的一个基础。
是一个就是我们说的大气潮汐重力仪，底下就是我们说的它的扰动图，我们可以从这里面扰动里面找到它的异常信息。出现这样的现象，我们这很多都是这个，因为这个仪器本身具备这些特性，我们才观察到别人没有观察到的东西。我们这3台仪器现在因为都挂在互联网上了，都可以24小时连续不间断的监测。我们时时都在观测，因为这个仪器就是其实我变成一个习惯了，每天都会看一下这个数据。
现在基本上是处于稳定状态的。至于看到的这些小粗的分子，可能是背景噪音，不在我们的这个识别范围内。
大于1.5毫伏以后，我们手机呢自动接到一个预警的这个信号。如果一致，那就很确切的，我们可能有大的地震来发生。这个还有一段距离，因为这个地震预报呢，这是一个政府行为，不是我们个人就能发布的。我们有一个群，微信群，然后呢，在这个群里不允许对外的去说的，因为这个要预报错的话，那会造成社会的恐慌啊。
The biggest problem is even if you have found the precursor, people get very scared to announce it. Just imagine the social, cultural, political fallout that will come out of that prediction. For a tsunami that happens after an earthquake, we can give a warning and tell people to evacuate. But predicting the earthquake in the first place is based on models and assumptions. If the earthquake happens, you become a hero. If the earthquake do not happen, you become an anti-hero.
So the earthquake prediction has to be really based on strong science evidence, and it has to be communicated clearly and cleverly, because it could cause a panic. In the future, the precursor is our only hope that we can predict earthquake. All the natural signatures that tell us the large earthquake coming, from the change in electromagnetic, change in gravity, and also people now could use radon gas. So the prediction study precursors, but the precursors is not simple. It's very complicated. It's inconsistent. The patterns always change from earthquake to earthquake. So right now, we just could not predict earthquake with the accuracy that we need.
我们这个有一个小的这个地震预报群，预报群就是有啥问题、有啥异常，都不断的很快就会交流、会沟通的。
当天晚上11点的时候接收到这个信号，立马就把这组信号推送到群里。有红色异常警报。5台传感器同时响应，这种同时响应的情况，就很大概率的就是预示着地震可能极大概率，就会发生了。
大于1.5，我们就把它作为异常。但这个呢，已经达到了这个10几20，达到了20这样一个强度。我们预感到要有地震，也感觉到是大地震。
那么随后在27号晚上，又发生了一个分值非常高的这样一个动态重力异常。
它是2个异常同时发生。那我们预测的话，就觉得它可能是一个地震2个异常。
当时我们的这个震级预测呢，预估的是7.1，时间预报呢就是，我们当时的判断呢就是大概在8、9天之后可能会发生地震。
但是你确实不知道啥地方，我还真不知道它啥地方，所以也不敢对外去说这个事情，
没有办法探测到它的具体的一个位置，所以说，也可能是一种无力感吧。
At least 50,000 people have been killed after 2 earthquakes followed by aftershocks struck near the Turkey-Syrian border.
The first earthquake hit suddenly and registered a magnitude of 7.8.
9 hours later, a second huge earthquake rocked central Turkey.
There is total devastation. Homes have been destroyed, and millions of people are in urgent need of help.
第一个呢，首先感觉到了这个太悲痛了，死亡人数太多，这种打击还是很多的。
当时收到这个消息的话，也可以说是在意料之中吧。我自己也是怀着一种复杂的心情的，就是可能会有一点愧疚我。
地震造成这样的损失，如果我们提前能够把位置说准、预报了，那么就会有这么多人免于死亡。
就是我们预估到了这个可能在这个1周左右的时间内会发生这个地震，实际上是它也事实发生了，预测的这个震级也是基本吻合的。但是也就是遗憾的一点，我们没有办法就是推测到震中的发生位置。当时预估的时间应该在8天，但实际发震的时间是13天左右，基本上也是准确的。
A group of researchers in Xi'an, China. I'm glad it's a breakthrough in science, but I think it's still not a prediction yet because they couldn't specify the pinpoint location where, and also they couldn't specify the magnitude, how large, and time. They just say that in the near future there will be a big earthquake somewhere in the world.
但是我们这一套东西其实也是不被大家是认可的，全社会支持，大家都相信这个东西，那就快了。大家都不信，那你再做也只能在我们这个小群里边自己去预测预报。
我们期待就是以后有新的技术突破，能够有效的解决这一问题。你可能在某一点上做出了一些突破，那么有可能在对后来之人是有一些启示意义的。
这个大数据、人工智能呢，可以说为地震预报呢提供了一个新的一个工具吧。通过数据挖掘分析，那么会找到一些内在的规律，我们揭示地震孕育发生的机制。那么我相信未来呢，肯定会解决地震的预报问题。
actually be a part of successful prediction would be seismologist's dream. The latest hope I have is that artificial intelligence and the advances in seismic data collection is helping to pinpoint that earthquake will happen in a specific area, maybe within 100 kilometers or 200 kilometers around this area. It is not often that you come back to the same place after like 20 years.
We always say that, I'm a sort of a Sherlock Holmes and he's a Dr. Watson. Assist me in the field.
I was trained as a geophysicist, working on all the earthquakes in India and some abroad. So after that, I started working with C.P. Rajendran. We got married in 1980. Our marriage is very symbiotic, either in work or in life. If you are a husband and wife, some people joke, how come you have survived without fighting with each other? All these years we had been working together. The work actually binds us much more. I mean, if there is an earthquake tomorrow, we are only worried about who will fund us to go there. So CP says, no one funds, I will take my own money and go. I mean, that's our life. That is the enriched life that earthquake studies have given us. Sumer, we have worked together for a very long time. We have always been, working together on same issues.
The thing is, Sumer has been very active here for the last several years.
I have been in seismological research more than 30 years. We have more than 200 seismic stations in the state of Gujarat and all the latest equipment. And we have recorded thousands of earthquakes in past 15 years of its operation. This artificial intelligence, machine learning, deep learning technology, you can extract more and more information that will help us in a long term in predicting earthquakes, in knowing the characteristics of each and every earthquake. So it is really exciting.
The run of Kachch is like a fantasy land. It's just endless spans of salt marshes. That captivates you. So there is an area where you can expect earthquakes, big earthquakes. Several active fault lines are shifting beneath this landscape. A major earthquake here could be felt in Pakistan and as far away as Afghanistan.
I don't think there is any place on the surface of the earth where you can go back in time and study the tectonic changes that has changed this landscape. So to me, the fascination is that it is like an archive of events from the history.
The past is the key to the present. So using these examples, we can actually project into the future.
We have 3 such kind of observatories in the Kachch because we consider it as a natural laboratory of earthquakes. A lot of earthquakes are happening in this part of Gujarat and a lot of active faults are there. My dream is that we could able to find out a, reliable precursor for earthquake activity in this region. And we are also using this artificial intelligence and machine learning to see something is there at the micro level. Right now, we are recording the level of radon in this area. Radon is a radioactive gas that naturally occurs in rocks and soils. The presence of this gas could give us a warning of future earthquakes. Whenever there is an earthquake likely to happen in near future, micro cracks will be formed inside the earth. Radon gas generally trapped inside the earth. And when these micro cracks are formed, those gases get released to the soil, to the rock. And there is a sudden increase in concentration of radon. These cracks got wider and wider, and ultimately the cracks become so large that the earthquake happens. If we visit an area that is very cold, we start sneezing, and slowly it gets converted into fever. So this is just like that. So if you find out that there is an increase in the radon concentration, then you can say that some activity is going on inside the earth, and this may lead to an earthquake in near future. So we have some background level of radon. You pick up a signal which is very feeble, but with the advent of this artificial intelligence, machine learning, deep learning, we can train our system to pick those signals also.
The problem is you have to roll out the other influencing factors.
Because other influencing parameter is the meteorological, means if there is a lot of rainfall also, it will also affect the concentration of the radon.
So somebody in your observatory is always watching this?
Yes. We could crack the code. If there is a big anomaly before a large earthquake, then this may answer many questions about whether this is a reliable precursor or not.
Soil radon concentration in a continuous mode. That is the main objective, to check the precursory nature of earthquake.
In some earthquakes, we could able to get a signal 3 days to 5 days before that earthquake. But the problem is that we are not getting the same anomalous behavior in each and every earthquake. We know that these areas has the probability of a big earthquake in near future, but to say when this earthquake will happen, where it will happen, and how large it may be, it is still very challenging.
It all depends on the large, huge amount of data which humans are not able to analyze. The artificial intelligence will be able to process those data. So in terms of short-term prediction, all this new technology is important, and they're all contributing towards that goal.
Earth is a very complex system, but still we are hopeful that one day we could able to predict the earthquake. So we should collect data collectively, we should collaborate, we should, you can say, exchange our ideas, and then we should work in an integrated manner to solve this a very complex and challenging earthquake problem.
So Bhuj earthquake was too big a tragedy to reconcile with. It was a scene of devastation. The pain and the human aspect of how it really affects your life, most unexpectedly, it captures you. This is the first time I witnessed the tragedy of a great earthquake. So you feel very, so it is something that you cannot imagine, that a mother is waiting for somebody and then mother is still there, the person has not come back. The incompleteness, the suddenness, something that you have not foreseen at all. Here is a museum that tells you that a lot of things have actually happened here, and we have outlived all that and we have still survived. It gives you education, it gives you hope. भूकंप का पूरा जगह में नहीं आता, लेकिन हमें पता करता है कहाँ आने वाला है. मतलब मे बी 100 years later में आ जाएगा, 2000 years later में आ जाएगा, बट मुझे हमें पता है इधर आने वाला है. ये हमारा ये कच्छ एरिया भी ऐसा एक कुछ एरिया है. We learn a lot from an earthquake. So today we know what will happen in Bhuj if an earthquake of magnitude 7.6 happens. We had a past and we have dealt with that, and we understand. because we understand, we are able to deal with it in future.
There's a lot of resilience here, and people have come back to their normal life. Many of the people who have experiences have become old now. A child has an immense amount of curiosity. That is what you require as a scientist. So look at the earth with fresh eyes all the time.
I had pretty much given up on prediction. So whoever used to ask me, I would say that it's the holy grail, it's not going to happen. But today I don't say that. Maybe finally our next generation of seismologists should be able to see that prediction coming true. And eventually the ultimate goal is to save people's life. So I'm very hopeful about the future.